Today, let us see some more examples on steady state error. For a unity feedback second order system. Unity feedback second order system. Since it is given as unity feedback, h of s equal to 1. The open loop transfer function is given. This is the open loop transfer function. Open loop transfer function is given. Calculate the generalized error coefficients. We have to find C0, C1, C2, etc. And find the error series. Find the error series. ESS series we have to find. F of S. F of S equal to 1 upon 1 plus G of S, H of S. That is equal to 1 upon 1 plus G of S is omega n square upon S multiplied by S plus 2 zeta omega n. H of S is 1. That is equal to S multiplied by S plus 2 zeta omega n upon S multiplied by S plus 2 zeta omega n plus omega n square. That is equal to F of S equal to S square plus 2 zeta omega n S upon S square plus 2 zeta omega n S plus omega n square. That is F of S. C0 equal to what? Find the generalized error coefficient. C0 equal to limit S tends to 0 F of S. That is equal to, if you substitute S 0 in the numerator, denominator omega n square. That is equal to 0. C0 equal to 0. C1 equal to limit S tends to 0 d by ds of F of S. That is equal to S square plus 2 zeta omega n S plus omega n square whole square. S square plus 2 zeta omega n S plus omega n square. Derivative of numerator is 2s plus 2 zeta omega n minus S square plus 2 zeta omega n S if you differentiate the denominator, what you will get? 2s plus 2 zeta omega n. So what is common? 2s plus 2 zeta omega n is common in the numerator. 2s plus 2 zeta omega n is common. The remaining things are S square plus 2 zeta omega n S plus omega n square plus S square plus minus S square minus 2 zeta omega n S. This is numerator upon S square plus 2 zeta omega n S plus omega n square whole square. S square getting cancelled. 2 zeta omega n is getting cancelled. Omega n square alone is there. limit s tends to 0. Limit s tends to 0. Here also limit s tends to 0. If you substitute s tends to 0, this term becomes 0. This also becomes 0. This also becomes 0. So what are the remaining terms? 2 zeta omega n. 2 zeta omega n. Here multiplied by omega n square upon omega n to the power 4. That is 2 zeta upon omega n. That is C1. At least 3 terms we have to find. So let us find C2 equal to what? C2 equal to limit s tends to 0 d square upon ds square f of s. That is equal to d by ds of this. This. That is what? 2 s plus 2 zeta omega n. 2s plus omega n square upon s square plus 2 zeta omega n s plus omega n square to the power 2. That is equal to limit s tends to 0. Limit s tends to 0. If you differentiate this, what you will get there? S square plus 2 zeta omega n s plus omega n square to the power 4. S tends to 0. If you differentiate this, what you will get? S square plus 2 zeta omega n s plus omega n square whole to the power 4, because already square is there. So we have to write as such s square plus 2 zeta omega n s plus omega n square whole square. If you differentiate the numerator, what you will get? 2. This becomes 0. 2 omega n square minus, we have to differentiate this denominator. That is 2 s square plus 2 zeta omega n s plus omega n square. If you differentiate this, what you will get? 2s plus 2 zeta omega n. Numerator as such we have to write. That is 2s plus 2 zeta omega n square. That's all. If you limit s tends to 0, what you will get is limit s tends to 0. If you this becomes 0, this also becomes 0, this also becomes 0, 0, 0, 0. So the remaining terms, this becomes 0, this also becomes 0. So what you will get is omega n square whole square to omega n square minus 2 omega n square 2 zeta omega n 2 zeta omega n square upon omega n to the power 8, that is equal to here 4 plus 2 6 2 omega n to the power 6 minus 2 8 omega n 2 3 4 plus 2 6 omega n to the power 6 upon omega n zeta square. 2 zetas are there. Omega n to the power 8, that is equal to 2 minus 8 zeta square upon omega n square. If you take 2 outside, what you will get? 1 minus 4 zeta square upon omega n square, that is C2. One minus 4 zeta square, okay. So we got C naught equal to 0, C1 equal to 2 zeta upon omega n, C2 equal to 2 times 1 minus 4 zeta square upon omega n square. Therefore, the error series E steady state, E of t equal to limit E steady state equal to limit t tends to infinity C naught equal to 0. Therefore, no first term. Second term is there. C1 is 2 zeta upon omega n r dot of t plus C2 2 times 1 minus 4 zeta square upon omega n square r double dot of t divided by 2 factorial. Here divided by 1 factorial plus etc. Plus etc. 2 factorial and 2 getting cancelled. That's all.